When you lease a virtual private server, you stop paying per-user SaaS fees and take back absolute ownership of your data. You gain complete privacy, strict control over your software, and a flat monthly cost. To build a self-hosted setup, step 1 is Vaultwarden. This is a secure server that handles your passwords while remaining fully compatible with official Bitwarden applications. Step 2 is n8n. This acts as your personal automation engine, connecting APIs and running repetitive digital workflows entirely on your own hardware. Finally, step 3 is Grafana. Every healthy server needs oversight, and Grafana provides the visual dashboard required to monitor your system's health and memory usage. By the end of this video, you will have a secure, fully containerized productivity lab running all 3 applications on a single Linux server. Before any application code touches your machine, we have to secure our fresh Ubuntu server. We start by generating an ED2551 SSH key on your local computer to establish a cryptographic lock for remote access. Once you add that key to the server, immediately disable traditional password logins. This single action stops automated bots trying to brute force their way into your machine. Next, we configure the uncomplicated firewall, or UFW. Here, you have to be careful to avoid the lockout trap, where users activate the firewall and accidentally block their own SSH connection. To prevent that, explicitly open 3 specific ports before turning the firewall on: port 22 for your SSH connection, and ports 80 and 443 for web traffic. With those gateways designated, turning the firewall on now safely seals the server's perimeter. Now we establish a standardized deployment method by installing Docker Engine and the Docker Compose plugin directly from Docker's official repository. We also add a 1 to 2 GB swap file. If your applications ever consume all your physical RAM, this file acts as emergency virtual memory to keep the system from crashing. Establishing this hardened, crash-resistant foundation is the non-negotiable prerequisite to running any software. With the server secured, we need to address app sizing. Choosing software that matches your hardware specs prevents the server from stalling under load. This chart shows the high resource floor of a private cloud. Nextcloud requires 2 CPU cores and 4 GB of RAM. Our stack is much leaner. Vaultwarden and Grafana can operate on just 512 MB of RAM, leaving room for the operating system. Prioritizing these lightweight, high-utility apps allows a small VPS to run multiple services without hitting memory limits or crashing during a traffic spike. We are ready to deploy Vaultwarden. Create a dedicated directory on the server and outline your Docker Compose file to define the service. By default, Docker containers use ephemeral storage. This means any data generated inside the container is wiped clean every time the service restarts or updates. We fix this by writing a volume mapping instruction into the Compose file. This forces the container to write its data to a local folder on your host server, which locks it into permanent storage. Execute the Compose command to start the container, and you can now log into your fresh password vault via your local port 8000. Mapping the volume this way ensures your database survives a server reboot, creating a permanent, reliable password vault. We apply that exact deployment process to n8n. Create the project directory and draft an environment file to configure your local time zone logic for scheduled automations. Enforce the persistent volume rule in your n8n Compose file. This guarantees that your complex automated workflows and API credentials survive any future server updates. Start the container, then access port 5678 to verify that the visual n8n workflow canvas is active and ready to build. Now we pivot to Grafana. Before spinning up its container, create a dedicated Docker volume specifically for your monitoring data. Access the Grafana interface on port 3000. Because this dashboard controls system metrics, you must immediately log in and change the default admin password. Your server is now an active, automated assistant and a self-monitoring machine, safely executing tasks without risking its own data integrity. In your terminal, run the docker ps command to verify that all 3 containers are actively running side by side. You now possess 3 fully functional, isolated digital tools, running entirely on infrastructure that you own and control. However, there is a critical limitation to this current setup. Right now, these powerful tools are only accessible via local, unencrypted server ports. To safely expose them to the outside world, you need a reverse proxy. This acts as a secure bridge, routing traffic and encrypting every connection with HTTPS. Click the next video on your screen to learn how to deploy a reverse proxy, making your apps secure and accessible from any browser worldwide.